So, hello everyone. Today we'll be doing a case of memory management in operating system, which is the best fit case. So, in best fit case, we basically finds the best allocated memory. We allocate the best suited memory for that particular process for which the internal fragmentation is least. So, what is internal fragmentation? When a process is being allocated to that particular memory block, the difference between the memory block and that process memory, the memory which is left. So we will first initialize the memory blocks, hard-coded the values of the memory blocks, and we have stored the length of that memory block using size of the memory block divided by size of each memory block. We have stored it in a variable n, the entire length of that array, which is of 5 value. So for the process, similar fashion, we have stored hard-coded the values and we stored the length of the process array. So we have dynamically allocated, dynamically initialized a third array, which is allocation array, for which we'll be changing the values of the allocation after the process is being allocated that particular memory block. First of all, we have initialized the allocated array with the -1 value in case any memory, any process is having a value of the size greater than that of the. So in case the memory size is lesser than that of the process, so in that case, the allocation remains to be -1. So we'll be looping through each and every process, and for that, we further loop through each and every memory block and find the best suited memory block for that process. Uh, Prior to that, we'll initialize the best index to be -1. So we loop through every memory block and we'll find if the memory block is having the size greater than that of the process. If yes, then it comes inside. Now, if the best index is for the first time only, the best index will remain to be -1 because we will initialize here only. And second time it will change, which I will shortly discuss. So let's do it with an example. As the first value is 212, it will loop through the entire memory block starting with 100. So 100 does not satisfy this condition that it is greater than that of the process 212. So it does not go inside. Instead, it increments the value of j and goes further, which is 500, which is greater than that of the value processed. It goes further inside and it finds that the memory index, so it is a or condition. It finds the memory index to be -1 because we have already initialized with -1 for that particular process, which is the process number first only, 212. It comes down and it changes the value of that best index to be that index where it satisfied this condition, which is for memory block 500. The index is 1. The first index is 0. So again, it goes for increments the value of j and checks for 200. 200 does not satisfy 212. It is not greater than 212. So it again increments the value, does not satisfy the if it condition and does not go inside. For 300, satisfies the condition, and for that it will check if the memory it will satisfy this and come inside. Now it checks whether the best index is -1. No, it was not because we have changed it to the best index 1 for 500, the second one. So it will check for the other OR condition as it is OR, so true, and the other one, if the other condition becomes false, it remains true. If one is false, the other is true, it remains true. The only condition where it becomes false is false and false. So memory block is having a size lesser than that of the memory block at that particular best index, which is 1. So memory block at index 1, it is 500, is 300 now, which we have now by incrementing the value of j we have reached here. So is 300 is in then that of 500? Yes. It further goes down and changes the value of the best index to be that of the value of 3 for the memory block 300 for the process number 1, that is 212. It again loops through, further continues. It will go through the entire array. So for this particular condition only, uh, it will go and check the entire array on every time. So for 600, it satisfies the condition. It does satisfy. It goes inside. The memory index is not -1, goes and checks the another one. memory block at J, which is 600, is less than that of 300. No, it is not. So it does not go inside. And the best index remains to be J, which is 3 for 300 memory. Now it comes out of this for loop, goes down, checks the condition if the best index is not equal to -1. No, it was not. It is the best index is 3 for the memory block 300. The allocation for the first process is done with the index number 3. So now I have done the printing. Process 212 is allocated the memory block 300, and the memory left is, we have done the subtraction over here. Memory block now at that particular index will be changed with the memory block minus that process. So it comes out to be 88. And here instead of 3, it will change to 88. And it will check for another process. And if it satisfies the condition, we'll reallocate this memory as well. So it goes and check for the another process, which is 417, similar fashion. Best index is initialized with -1. It goes inside. It checks for 100. No. 500. Yes. It changes the best index to be 1. For 200 does not satisfy. For 300, sorry, it is not 300 now. It is 88. For 600 does satisfy. But when it goes inside, it checks if 500 is lesser than 600, or like 600 is lesser than that of 500. No, it is not. Then we'll not change the value of the best index. It will remain to be that of one value for the memory block 500, which is best suited for the process second, which is having the size of 417. So the process 417 is allocated the memory block 500, and the memory left is 83, which is now changed, replaced with the value of the memory block at that particular index, because we have done here the memory block at that particular index is changed with the difference between. So yes, we were talking about for the memory 417, similar fashion 112. It is allocated the memory block 200, which is best suited for that because 100 and the next one is 83 now. 200 satisfies the condition. 88 does not satisfy the condition. 300 is replaced by 88, which we have done for the earlier one only. 600 does satisfy the condition for 112, but this condition memory block is checking memory block at that particular index is having the memory block size lesser than that of the memory block at that particular best index, then only the best index value will be changed. So this is a very important condition. Now, for the value 4 to 6, 600 will be allocated, and here I've shown 4 to 6 is allocated to the memory block 600. The memory left is 174. Here is the tabular representation that the process size 212, having the size 212, is allocated to the block number 4, which is the first block is this. So 1, 2, 3, and 4, 300. Yes, it is allocated to 300 memory block. Similarly, 417 to the second block, 112 to the third block, 426 to the fifth block. So this is the entire code for the memory management case of the best fit. Thank you so much.